All right, so today we're going to take a quick look at section 5.1. Okay, and if you remember from equations, okay, how you solve an equation by adding or subtracting from both sides, solving an inequality is pretty much the same idea. Okay, we're going to do adding and subtracting on both sides. Yeah, question?
Can I have a pen?
Pen? Yep. Okay, on your note sheet, I want you to fill in how you pronounce that. It says A, and then there's a symbol, and then B. Okay. Who can tell me how do you pronounce that? Yeah. Yeah. A is less than B. A is less than B. Well, we're going to always read it left to right. Okay, we'll talk about that symbol too.
A comes before B in the alphabet.
Yep. Okay, so what that means visually, if you were to draw this on a number line, okay, if one number is less than another, if A is less than B, that means it would be to the left. Okay, so here's our number line. A would be here. B would be there. A is to the left of B. Okay, any questions on that one? A is less than B. Okay, how about that symbol? How do we read that one?
Greater than or equal to?
More than.
Just greater than.
Well, it
Yeah.
looks like there's another one.
Okay.
Oh no, there's another one.
So C is greater than D. We'll talk about the equal to in a
that's a
second.
C.
Right, so C is greater than D. Okay, on a number line, what would that mean? If C is bigger than D, where would that be? C would be where?
To the right.
Yeah, C would be to the right. Okay, so on a number line, C would be bigger. It's to the right of D. Okay? You could also say D is smaller. Okay? Depends which way you read it. Okay? Either say C is greater than D, or D is less than C. Okay, any questions on that? Everybody had that filled in on their note sheet?
Yep.
All right, so all of these types of things, whether you say X is less than 2, A is greater than 5, all those things, those are called inequalities. Okay, that's an example of an inequality. What makes it an inequality
There's a negative.
versus an equation? Why would this not be called an equation? No, not because of the negative.
What's it called? The sign, the greater than sign.
Yeah, the symbol, the less than sign. Okay, that symbol is what makes it an inequality. Okay, what symbol do you need to have if it's an equation?
Equals.
Equals. So like x equals 7. Okay, that's an equation. Okay, let's take a look at the 4 basic symbols. We've already done 2. Okay, and what they all mean. Okay, who can tell me, raise your hand, the top symbol. What's that one called? Laura? That's less than. Okay, less than kind of looks like an L, a little bit bent in. That's the less than. Okay, how about the next one? That's a greater than. Okay, now the next 2 symbols, they look very similar, except they have a line under them. What does that line do? That adds a couple words to it. So you still say the name, but then you say or.
Less than or equal to.
Equal to, yeah. Okay, so if you get the less than symbol with a line under it, less than or equal to. What's the difference between less than or less than or equal to? What's the difference? Yeah.
Well, it could either be smaller or equal to, like, it could be, yeah.
So what would be the difference if I said, for example, x is less than 10 or x is less than or equal to 10? There's just one small difference there.
So it's 10 or lower.
Right, in the equal to case, it can actually include the number. So if I said x is less than or equal to 10, it could be 10 or lower. But if I say x is less than 10, that doesn't include 10. It has to be lower than 10. Okay, like 9.9 or smaller. How about last symbol?
Greater than or equal to.
Yep, greater than or equal to. Okay, so those are our 4 inequality symbols. Sometimes we also see this symbol. Means not equal to. But we're not going to be using that symbol. Okay, we'll stick with those 4. All right, so to solve an inequality, okay, that means basically to find the solution. But the solution isn't just a number, it's a set. Okay, for example, if I said to you, let's look at an equation. 2x equals 6. How many solutions are there? How many different answers are there to this equation? Not what is it, but just how many? Okay, so 2 times something gives me 6. There's 2 different numbers?
No, one.
Just one.
Wow, yeah.
2 times 3. Okay. There's only one answer to that equation. Now, what's the difference if I said something like this? How many answers are there to something like that?
1x.
X is bigger than 5.
Yes.
How many answers?
1.
1? So there's only one thing that's bigger than 5?
Yeah, there's many.
Four.
There's many things that are bigger than 5.
Right, there's many things that are bigger than 5. Okay?
But there's only one that's very close.
So that's the key. When we solve an inequality, the answer isn't just one number, 2 numbers, 3 numbers. It's a whole set. Okay, it's anything that's bigger than 5. Anything. 6, 7, 8, as high as you want to go. It's a set. Okay? It's a whole set. Okay, so here's another example. Okay, just look at this one. Somebody tell me, how do you pronounce that? Raise your hand if you know how to pronounce that. Matt. Yeah, x is less than negative 2. Okay. So what we're looking at is any number that's less than negative 2. Okay, here's a couple. Negative 3, negative 5.4. You can use decimals. Or negative 100.
Is that a 5.4?
Yep. Okay, other numbers make this false. 2. 2 is not less than negative 2.
No, I need to write this down. All good.
You don't have to do it.
I need to write this down.
Okay, okay.
Mr. Hager told me I didn't have to put it on me, he's a big giving mood. He wants to spread because it's shared.
1.4. 1.4 is not less than negative 2. How about negative 2? Is negative 2 less than negative 2? No. What is it? It's equal to. Okay, so all I'm trying to do is show you that there's a bunch of numbers here that are true. They are less than negative 2. And there's other numbers that are not. Okay, so it's a set. It's a bunch of numbers. Okay, since we can't list every possible answer, okay, you can't list every single number in the world that's less than negative 2. It's not possible. A lot of times what we'll do is graph it. Okay, we'll make a picture of all the answers. Okay, we'll use a number line. How many people have done like to draw a filled-in circle or a closed circle and you shade, put an arrow? Done that? Okay.
Right, guys, so this is what we want to have down on our notes, where it says to graph the solution to an inequality.
Okay, the key when you're graphing it is just like the form we have right up here.
So on the line there on your guided notes, you're going to write simplify the inequality so that it is in the form. That's all you're going to write right now.
Okay. So Mr. Roy's got all 4 symbols listed that you could use. We just went through what each one means. And the idea is, here's an example of something that would be a final answer to a problem. Variable on the left by itself, inequality symbol in the middle, number on the right. Okay, there's a couple reasons why we want to write it like this. One, if you put the variable on the left, this symbol actually tells you which way to shade. If you write it like this, does everyone agree that these are the same thing?
No.
X is less than 2 or 2 is greater than X?
Oh, yeah.
Same thing. This way, we don't want to write it this way. It's not wrong, but it's more confusing. Okay? We always want the variable on the left. So we'll practice that.
Okay, guys, this is sneaking here real quick.
Brothers, people have something besides me. It's true.
Guys, if you get something that's written like this, all right?
Please don't.
You get something that's written like this,
What do we do? We flip it.
flip it, right? You always want that inequality sign on the other side, all right? So I'll take my x minus 7. Still the same thing, right? And I put my negative 3 over here. Now, which way, I always look at it this way, which way, this is the inequality sign, right? Which way is the inequality sign, or I call it Pac-Man, what's it eating? The negative 3 or the x minus 7? The negative 3, right? So when I rewrite it, I always want to rewrite it or flip it. I always look at which way the inequality sign or the Pac-Man sign is eating. If it's eating it, if it's eating the negative 3 in the original, I better rewrite it with it eating the negative 3 when I flip it. It's like Mr. Hager saying, when I get something like this, it's easier to graph the inequality, right, when you have the variable on the left-hand side. So if you get something that looks like this, flip it. Or when Mr. Hager right up here, if you get something like this,
Mr. Roy, you wanted to flip it before they start the problem? Or
yeah, you can, either way, if you get something like this, guys, it might be easier to flip it at the beginning, right? That way you don't forget to do it at the end. But like Mr. Hager said, if you get something like this, right, I can rewrite it. I want my variable on the left-hand side. What's Pac-Man going to eat, the x or the 2? X. 2. That's my final answer. All right? So if it's written with the inequalities, with the variable on the letter on the right-hand side, rewrite it, flip it. It makes it easier to graph.
And notice when Mr. Roy did that, you've got to be careful. He also flipped the sign. He flipped what was on each side, and he had to change the direction of that symbol. Okay, so as he said, make sure it's still eating whatever it was to start with. Okay, or if you want to think of it, whichever way it was pointing.
That way too.
Okay.
Just flip everything.
All right, so that's your first step. Okay, if you're going to graph it, you're going to get something like that. Next step, you're going to put a circle on the number. What's the number? It's the number that you just figured out right there. Okay? There's 2 kinds of circles you can use. Anybody? What are the 2 circles? We already, I think, said them. So we got, an empty or open circle. And what else? Right, Isaiah?
Yeah, she took it.
What's the other one?
Closed.
Yeah, a closed circle or a filled-in circle. Okay, so how do you know when to use each symbol?
Oh, I got this.
Well, it depends on what you had to start.
Oh, okay.
Yeah. So if you had one of these 2 symbols, if you have a less than or a greater than, you use an empty circle or an open circle. What kind of circle do you think you'd fill in? What symbols would you have to have for that?
Less than or equal to.
Yep, or
Or equal to.
good. So for a closed or a filled-in circle, that's when you have these 2 symbols. So now at this point you're going to have a number line, you're going to have a circle. In this case, what kind of circle would this one be? Yep, open. And now there's one more step. What's your last step? Well, we've already solved it.
Plug on the number line.
Graph.
Okay, we've got our circle. What do you mean graph it? What's the last part of graphing it? Some people said they already did this before, so. Anybody remember what's your last step?
Plot it on the number line.
So am I done? Plotted it.
Break the arrows.
Right, you're gonna shade it. You're gonna draw an arrow. So you either got to shade to the left or to the right. If you write the inequality exactly like Mr. Roy and I told you, the inequality tells you which way to shade. In ours, shading to the right. Okay. X is greater than 2. All the numbers that are bigger than 2. Okay, write it just like Mr. Roy said to, and the inequality points the way to shade.
Yeah, exactly. Go back up. Think of that, the inequality sign, as like your arrowhead, right? It's pointing, the arrowhead's pointing in that direction. That's the way you want to graph. In this case, it's pointing to the right. You want to graph everything to the right.
And that's only if you write it the way we suggested. If you flip it around, okay, and do it the way we said not to, then it doesn't point the way it should. Okay, so do it exactly like Mr. Roy explained. Flip it right away so your variable is on the left. Okay, where should the variable be? On the left, never on the right. Okay, any question on when you use an open or a closed, or how you figure out which direction to shade? Direction's pretty simple, pretty straightforward.
So Ben, when are you going to use an open? Yeah, just the regular greater than or less than, right? Tyler, when are you going to use a closed one? Or a filled in one? Not sure. So Mr. Hager asks any questions you might have thought about asking, right? Guys, someone help him out. Someone help Tyler out. When are we going to use a closed circle?
When there's a
All right, go ahead. I'll give you a second chance.
when there's a line underneath the
Yeah. What is it? That means greater than or equal to, or less than or equal to. Right? That's when you want to use to. It's like that line underneath kind of tells you. Make sure you fill it in your circle. All right.
Okay, before we even graph this, take a look at the problem. Is it set up the way it should be? Is the variable on the right side that it's supposed to be? Okay, where did we say the letters should be?
On the other side.
Left or right?
To the left. To the left.
Variable should be on the left. Where's the variable in this problem?
On the right.
The left.
The x, that's on the right side?
I'm pretty sure that's the left.
Okay,
Right?
Curious about the same.
all right. So this is x is greater than 0.
Told you, Marcus.
Yes.
Yeah, the same thing.
All right, so I think there's some confusion. I'm going to start over. Where is the variable supposed to be?
The left.
The left. Good. Where's the variable in this one?
The left.
So are we good?
Yes.
We're good. All right. Next thing we got to do is take our number line. Okay, we got to label. Okay, you don't have to label a lot. Generally, I'd like you to label the number you're graphing and maybe one number to the left, one number to the right. Okay, that just shows the direction.
And sometimes, guys, you make it a number line and there's already numbers on it.
Yep, there might be numbers on it. Okay, well, who can tell me what's my next step? I got to decide what? Yeah. Okay.
Shut up.
I got to decide. Okay, raise your hand, guys. Act appropriate, not appropriate language.
So it's a closed circle going to the right.
So it's a closed circle. Why'd you decide closed? Tell me, how'd you think of that?
There's no line underneath it.
There's no line underneath it. So let's go back and look. No line underneath it. Closed circle? Sure? Closed circle when there's no line? Open.
Yeah, not bad.
Okay. Open circle. And now which way did you say to shade? To the right. The inequality tells you, couldn't be any simpler. It points where to shade. It's pointing which way? Right.
Guys, can somebody tell me by raising their hand, how would I read that inequality? How would that read? How would that translate? Somebody besides Isaiah. Why? How's that going to read? I had to translate that from the math symbol to English. How would I say it? X is greater than 0, right? When I graph, I want to graph all the numbers that are greater than 0. Graph all the numbers that are greater than 0.
And what Mr. Roy just had you do, I'm going to have you do on a test when we do this. I might give you the symbol and ask you to write it, or I might give you something like this. Say, here's a picture. Tell me how you would pronounce that. X is greater than 0.
Can we write the circle and the shade part above the line?
Above the line?
Yeah.
Yeah, that's fine. I mean, I'm probably going to do it on the line, but if you do it above it, that's okay. Okay, what about this one? Tyler, how do I pronounce that?
What do you mean?
How do you translate it, Tyler? What does that
On the
mean?
graph,
Just read that whole sentence
Not
to me.
graphing it, how would you say it?
y, 3 bigger than y.
Don't read it left to right. Just like, so graph the solution
Y is
set.
less than 3.
Y is less than 3. Good. Okay. All right, what do I need to do?
Ben, what's Mr. Hager's first step? All right, graph it, that's cool, awesome, thank you. But how does he do that? What's the first step in graphing it?
Right numbers.
Huh?
Right numbers.
Right numbers. What numbers do you want to write on your number line?
-1, 0, and 1.
What number do you definitely need to have on there? 3. Let's put 3. What else did he say to do? Put the number that's...
Look at the last one.
Smallest.
So the one that comes in front of it, which would be what in this case? What comes before 3? 2. And then on the other side? All right, now, guys, somebody help us. Somebody, don't tell him what type he's going to use. But Spencer, what's the next thing he needs to figure out? All right, where the circle goes, right? Where should he? I don't want to know what kind of circle, but where should he put it on the number line? On the 3, okay. Now, Ben, Spencer just said you want to put it on 3 on the number line, right?
Yeah.
What type of a circle do you want to use? What are your 2 choices?
The open and close.
Open or close? What do you want to use in this case?
Open.
Open, perfect. And now, which way is your arrow going to go, Ben? To the left or to the right?
To the right.
Look at the inequality. Good. Remember, that inequality sign, right? That's just like your arrowhead. Whatever way it's pointing, that's the way you want your line to go when you graph, okay? That's why we said it's really important, guys, that you get the variable on the left-hand side. Makes it a lot easier to graph. There's no guesswork then.
Okay, so not only does it point in the direction you need to shade, but just read it in your head. Y is less than 3. Think about where are the numbers that are smaller than 3. They go to the left. Bigger numbers go to the right. Okay, so that's why we shade left. Okay, let's try one more of the simple type. Yep, these are the simple ones. Okay, first step. Who can tell me my first step? Oh, Joe. What's my first step? Okay, write down your -3, and then what?
-2 and
Where's the -2 going to go? On the right, good. And what else did you say? Yeah. Okay, so label Label your number line. Okay, Elijah, what's next?
You're gonna put a closed circle,
Why closed? Good.
because the line is underneath.
Yep. And where's the closed circle going to go?
-3.
-3. And last step, Austin.
You're gonna go to the right.
How do you know it's shading right?
This is the point on
Yeah, because the way the inequality points. Right? You're shading all the numbers that are larger than -3. Larger than or equal. Okay. Any question on that one? Okay, so far all the inequalities have already been set up for you. The variable has already been alone. We're going to look at some where it's not. Okay, so if the variable isn't alone, what we're allowed to do is, today we're going to look at two things. We're either going to add a number to both sides or subtract a number from both sides. What's this kind of like?
Math.
Well, something specific.
What do we do this like the second week of class?
Oh.
Huh? Yeah, solving equations, right? It's just like it says up there. It's just like I'm solving an equation, right? So guys, what was that? What was that? An acronym, like something that letters that stands for something, right?
Yeah.
Like FFD, Fitchburg Fire Department. You know,
Splash.
what NBA, National Basketball Association, right?
Yeah.
NFL, National Football League.
Oh.
What was that acronym we came, does anybody remember from the beginning of the year? What was that acronym we came up with for solving equations? Anybody remember?
Spam.
Not spam, we're not eating anything.
Wait, what does spam
We're
mean?
close.
Spam.
Not PEMDAS, that's one of our operations. Some of you guys were close. Remember Sam? Right, you guys remember doing Sam at the beginning? We did Sam. Remember that S stood for simplify?
Oh.
That's when you want to combine like terms or do the distributive property. The A stands for add or subtract. The M, multiply or divide. So we're not going to give you step by step on how to do every single inequality. You already have the steps. If you need to, look back in your notes. Actually, we made that graphic organizer too for solving equations. And all the boxes on it. Most of you guys had that when we went through your binders. If you need to take that out and use it, you can use that too. But treat that inequality sign just like it's an equal sign. So you got to keep things balanced, just like we do when we solve equations.
And you're not going to have to worry about ones that are with multiplying today or dividing. Okay, we're not going to do multiplying or dividing today. So there won't be as many steps. Okay. Okay, what's wrong with this that we can't just go right to the graph like we've been doing? The variable's on the wrong side? I think it's okay. It's on the right. It's on the side it should be. It's not alone though. Exactly. It's not alone. So how do we get it alone? If this was an equation, what would you do to both sides?
You would plot it.
Yeah, Chelsea. You would what? Yeah, you'd add 8 where? To both sides. Good. What's going to happen on the left-hand side when I do that? That's going to cancel out, and you're left with, what did you say? Just x. What about this symbol? What happens to that? Bring it down. Does it change? No. Anytime we do adding or subtracting, this symbol doesn't change. Now, when we do multiplying or dividing, it can. But for today, you don't have to worry about it. Just copy it down. Okay, last part. What's negative 11 plus 8?
That's
-3.
negative
Negative 3. Good.
3.
Is this a final answer the way we want it?
Yes.
Yep. Now we can go through, graph it just like we did before. Okay, who can tell me my first step? Yep, put down your negative 3. It doesn't matter where on the number line. Try to put it somewhere kind of in the middle. Negative 4 goes to the left.
Yeah.
And what else? -2. Okay, so we got our inequality labeled, inequality line. Next step. What's my next step? Yeah.
Alright, close. Now open circle
Open circle
to the left.
on -3. So you say where, and then shade to the left. Good. Shade everything left. And that's it. That's the only extra step. You got to get x by itself, and then graph it. Okay. Any questions on that? Okay.
This one was confusing.
Okay, let's try this one. All right. Thoughts? What's going on here? What do we got to do?
Get rid of the fraction.
Run away.
Okay, don't worry about the fraction yet. What did Mr. Roy say?
I'm tired.
Something we got to do here that he suggested to do right away.
Take
Flip. Yeah, we got to flip it. Okay. What side do you want your variable on?
the left.
You want it on the left. Where is it now?
One on the right.
It's on the right. We got to fix that. Okay. If I rewrite that, Spencer, what's going to be on the left side?
You're gonna have to flip it.
Yep.
So the thing that's in the parentheses and
So this is my left side. This is my right side. When I rewrite it,
just flip it.
yeah, this whole box goes to the other side. 5 minus 1/2 minus x.
And then 7 will be
7. Now, where does it point?
that way.
It's going to point to the,
To the 5, whatever. Yeah, the longer, like,
is it going to point left or right? Nope, it's not going to point left. It's going to point right.
The alligator's gotta eat the big one.
Right. Okay, look at where it was pointing originally. It was pointing at the 7. If you flip it, it still has to be pointing at the 7. Okay? All right. Now, at least we get the variable on the left side. That's good. Okay, what's my next step? Again, pretend that that was an equal sign. You wouldn't do this any different. What are you going to do on that left-hand side? It's a property we've used before. Yeah, distribute. Very good. What are you distributing? What's right in front of the parentheses?
A 5.
Nope, no, the 5 is separated from it. 5 is further away. It's a -1. Okay, if you want to put in the -1, you can, but that's what you're distributing. Okay, remember, as we always say, the sign goes with that number. Okay, so distribute out your -1. What's going to happen to that 5 right now? It's going to be left alone, nothing. The 5 has nothing to do with the distributive property. Okay, what's going to come next if I do out my distributive property? Well, Ben, what comes next?
Distributed.
Yep, so when we do that, what's the first thing I write down? So we get the 5. That -1 needs to be, what would you do if you had this? Just pretend it was that. Multiply. What times what?
-1 1/2.
Good. What's -1 times 1/2? -1/2. Okay, and what comes next? I've got -1 times -x. Someone, positive x. Good. Negative times negative becomes positive. Okay, what about my symbol? What do I do with that right now? Just bring it down. Okay, that symbol is not going to change direction for the rest of this problem. It's always going to point exactly the way it is. Okay, Sam, what's on the right-hand side? Still have that 7. Okay, so at least we get the distributive property, that's done. Okay. What do I do now on the left-hand side? I have 5 minus a half plus x. Something that can be done on that side. Combine like terms. What's 5 take away a half? 4.5. Okay. If it helps, let's just write it as a decimal, 4.5. Okay, now we've taken a problem that was pretty complicated. X was on the wrong side. We're down to the last step. What is my last step to get x by itself? Someone else. How about Travis? Can you tell me my last step? I'm just trying to get your variable alone. Okay. Can you tell me what's making it so the variable isn't alone? Well, there's an x, but is the x by itself right now? You're going to get rid of the 4.5. Okay. How do you do that? No, not divide. I think this 4.5 is a plus. So you subtract it. Okay, you're going to subtract it. Okay, so if you don't remember your steps on solving equations, try to go back and look at those, because this is the same thing again.
That's so hard.
So we subtract. 4.5 is gone. We've got x. Okay, Matt, what's my symbol? Greater than or equal to? And what's going to be on the right-hand side? About Sam. What's on the right-hand side? You see the calculation we have to do? 7 take away 4.5. What is that? Okay, start with what's 7 take away 4? 3. Now take away a half more from that. Take away a half more from that. So you did 7 take away 4, that was 3, and then take away 0.5 is 2.5. 7 take away 4.5 is 2.5. Okay, this time on our number line, generally we're going to label these not as decimals. Okay, so what would be a good number to put on this number line? 2. Yeah, what else? 3 and
4.
Yeah. Okay, you're going to be kind of in the middle. You're going to write down 3 numbers. That's fine. If you did 1, 2, 3, that would be fine too. Where's 2.5? Right in between 2 and 3. What kind of circle?
Full.
Yeah, fill it in. Okay, which way do I shade? To the right. Shade to the right. So who can tell me what's the answer to this problem? It's all numbers what? All numbers that are greater than 2.5. Okay, greater than or equal. If you take and plug any number that's bigger than 2.5 or equal into that original problem, it'll work out. Okay, all numbers greater than or equal to 2.5. Okay, any question on that? Okay, so what we're going to do, we're going to give you guys some practice problems to do in groups. Maybe we'll split them up into groups if we want. Yeah, we'll do that worksheet. And there'll be a few review problems on it as well.